Okay, welcome back, students. So we're on 2021 question 5, part B. So let's read the question carefully to see what we know and what's unknown that we need to solve for or find out. So the rectangle from X to Y to Z to W. That looks like this. Is the image of the rectangle ABCD, this triangle, in an enlargement of scale factor k equals 3 as shown below. So basically from the very center these rays come out and everything is multiplied out by 3 to become 3 times longer. Okay, so this from WX will be 3 of these. Let me tidy all that up now. So just to comprehend, if this is 1, there'll be 3 of them here. And if this is 1, there'll be 3 of them here. 1, 2, 3. So we're to find the distance from A to D. Okay, now from A to B is 5. And the area of this is 12.5. Okay, we often put square brackets to show that something is an area. So we know the formula for area would be 5 multiplied by distance CB, or distance x if we call it x. So we know that 5 multiplied by x is equal to 12.5. So our strategy is to use dividing, okay, to find AD. So we're going to divide 12.5 by 5, and we get 2.5 on the calculator when we do that. Okay. So now we know this x is now 2.5. Okay. Now they ask us to find the area of the big rectangle. Now we know what to do from the small triangle of 12.5. To get the area of the big triangle, you multiply it by the scale factor squared. So that's the big idea in this. That's the quick, direct way of doing it. The indirect way of doing it would be to say that this is 15, because it's 3 times bigger, and to say that this is 7.5. And that would give us the same answer if we multiplied those two together. Okay, so either way we're going to get the answer. For curiosity, we're going to do it both ways. Okay. Now I happen to know that 15 squared is 225. Half of that would be 112.5, would it? I think so, but I'm going to make sure by checking on the calculator. So we're going to do the direct way, which is to multiply the small area by the scale factor squared, 112.5. And similarly, if you had used a different strategy, but equally correct, you would have got the two longer lengths as 15 times 7.5. So it just goes to show that there's more ways than one to do the problem. Okay. And of course, we're going to put the area in with the correct units. Okay. Now to construct the center of the enlargement, let me do that more properly than I did the first time when I was just roughly showing you. You take a ruler, okay, and you bring a ray from the corner of the big rectangle through the corner. Now, when you do this in reality, it's much easier to position the ruler than what I'm doing here. So I'm just going to be roughly correct. And you can draw in the two diagonals, actually, we can call them. Okay, and imagine that they went through the corners properly, and then that's the center there. Okay, so the construction really just involved a straight edge and a ruler and a pen, a pencil. That's all you needed. Okay. We're reading the question again, and just to go back to our what we do in problem solving, you double check, confirm your solution answers the question. So I'm making sure, going back there to this, construct the center of the enlargement. It didn't tell me what letter to use. It's often called O or C, but we've used up C up here. So we call O the center of the enlargement. Okay, done. Just C diagram. Okay. And that's the end of that question. So as always, students, I will see you in the next one.